All right, let's look at some examples of finding derivative where chain rules and all other rules may be used. I'm looking at homework, okay? And the first example I would think of is this one, homework week number 9, and here's the function. And the function is f of x equals to 1 over cubic root inside cubic root is x squared minus 1. Okay, of course, we're going to take a derivative with respect to x, the derivative with respect to x. So f of x, that's what we are interested in. So the function itself, we can see it as a exponential function. Of course, you can also do this by quotient rule. You can do this by quotient rule. But even if you do quotient rule, when you're not doing quotient rule, you also have to do chain rule. Because when we differentiate the denominator at some point, we will have to, apply chain rule. Okay, so suppose that we're going to rewrite f as the following, which is x squared minus 1 to the power of negative 1/3. Okay, so we can see it that way. So then we're going to take a derivative. We're going to see this as u raised to the power of negative 1/3. Okay, so according to chain rule, we're going to be differentiate. We're going to differentiate it, differentiate with respect to du, and which is u raised to the power of negative 1/3, sorry, and multiply the derivative with respect to u, and then with respect to x. Okay, of course, u is x squared minus 1 in our case. So u is x squared minus 1. So now we can put the u in its place. There we go. So that's the setup for chain rule. Now, what's the derivative of u raised to the power negative 1/3 with respect to du? And that's going to be, we're going to apply the product rule, the power rule. So we're going to have a negative 1/3, and u raised to the power of negative 1/3 minus 1. Minus 1. And then multiply the derivative of x squared minus 1, that's going to be 2x. Right, so you can see we're almost done. Of course, we're going to substitute u by its original expression, and negative 1/3 minus 1 is negative 1/3 minus 3/3, and that's going to give us a negative 4/3. Okay, by this time, we're almost done. All we have to do is that we're going to substitute u by its equal, which is x squared minus 1. We're done. If you like, you can bring 2x to the front if you like. Okay, so you can put 2x here. Okay, well, you can put 2x, well, you can put 2/3 of x. Okay, you can write it that way. All right, let's look at another example. And this one is going to be f of t. F of t is equal to t times sine of pi times t. And so first of all, it is a product rule. And within product rule, when we differentiate sine pi t, we're going to apply chain rule. Okay, so once again, we're going to differentiate the function with respect to not this time, not t, not x, is going to be t. So we're going to take a derivative, right, of t. The derivative of t is 1 multiply sine pi t plus, now we're going to keep the t and differentiate. We're going to differentiate with respect to t sine pi t. And of course, in this case, we're going to be applying chain rule. So the first part, we're going to have sine pi t left. And the second part, we're going to apply chain rule. So t multiply, when we apply chain rule, and this is going to be set up as derivative of sine of u. Okay, u is pi t, sine of u du, multiply du dt, du dt. And u itself is pi t. There you go. Okay. And next step. The derivative of sine u is cosine u. And the derivative of pi with respect to t is going to be pi. For clarity, I'm going to bring this pi to the front. So it's going to be pi t. Okay. And in the end, we're going to replace u by pi times t. Pi times t. So that's done. This step in the middle, right? This step. And even this step, these two steps can be optional. So this step can be optional. This step can be optional. Okay. All right. So let's look at another example, which is g of x equals to e raised to the power of x squared minus x. Okay, so we want to find the derivative with respect to x on g of x. And that will be equals to the derivative of dx, right? E to the power u, right? So we're going to call the whole of it is u. So we have e to the power u. And multiply the derivative, this du, so here we change it to du, and divided by du, multiply du, dx. And of course, u is x squared minus x. There you go. So that's the application of chain rule. And next step, the derivative of e to the power u with respect to u is e to the power u. Multiply the derivative of x squared minus x, that's going to give us 2x minus 1. Almost done. The next step, we just have to replace u by x squared minus x. And this step be skipped. Yes. Okay. Even this step can be skipped. These two steps, if you show work like this, as you're getting better at this, if you show work like the following, okay, it's perfectly okay. It's perfectly okay. If we should work this way, no problem. It's correct. Okay, and it's also not difficult to read. All right, so let me work on this question, okay, which is g of x g of x equals to, we have x squared plus 1 to the power 3 multiply x squared plus 2 to the power of 6, to the power 6. Okay? So we're going to apply product rule and chain rule. Product rule and a chain rule. Okay, so we're going to show the product rule is right here, right? Let me bring it up. That's product rule, right? So right next to it. And so when we differentiate d of dx, g of x, and so we're going to generate two terms. So we're going to view this as one function and this other one as the other function. So two functions. We differentiate one and keep the other, and differentiate the other and keep the first one. All right. So this function we're going to differentiate first. So that's going to be 3 times. Okay. So maybe we can separate it, right? Maybe we can separate it. Okay, so first we're going to differentiate. You can do it together if you want, if you wish. Okay, I'm going to differentiate this part, this piece. And this is obviously, this can be viewed as chain rule. Okay, so we're going to have derivative du, and here is u raised to the power of 3. Multiply du dx. And u, of course, is that piece, x squared plus 1. So you view this as u to the power 3, and you differentiate with respect to u, and you get it that way. And we finish. Okay, u to the power 3 is 3 times u to the power 2. And the derivative of x squared plus 1, that's going to be 2x. In the end, substitute back u, which is x squared plus 1, we get 6x multiply, okay, x squared plus 1. So that is the result if we differentiate this piece. If we differentiate the other piece with respect to x, we're going to differentiate the entirety of this piece, and that's going to be same idea, okay? Derivative with respect to u, and what is u? This piece is u. Okay, so that's my u. So that's going to be u raised to the power 6. And then multiply du dx. And I'm going to replace my u by that, x squared plus 2, right? So that's a setup. And what do we get, right? So the first part, we get differentiating u to the power 6, we get 6 times u to the power 5, multiply the derivative of x squared plus 2, we get 2x again. The same drill, we have 12x, multiply u to the power of 5. U to the power of 5, that's x squared plus 2. to the power 5. Okay? So by this time, we're going to apply the product rule. So when we apply the product rule, right? So we have two functions. Okay, so I'm going to write it this way because I can do copy and paste and you cannot, right? So we're going to differentiate this part. And then we're going to bring this up and differentiating the other part. So if you can see that clearly. Okay, we keep one function, differentiate that, and we keep the other function, we differentiate the other part. So the rest is just substitution. Okay, so we're going to substitute the answer we get, right? So here we just copy. And the derivative of x squared plus 2 to the power 6, we have an answer, which is we did over here. So we copy and paste and bring that over here. Plus, we keep it here. This is a caps. And derivative of x squared plus 1 to the power 3, we got the answer over here. So we're going to just plug in. And the next part, we're going to reduce these. So we prefer a factored form. So what can be factored? Okay, let's see what can be factored. 6x can be factored out, right? So we can factor out the 6x. What else can be factored? X squared plus 1 to the power 3. Okay. Wait, did I miss anything? X squared to the power 3. X squared plus 1 to... Let's see. I think we're... Oh, sorry, I missed a squared here. Okay, so here I missed a square, no wonder. But here, that's why I felt something was wrong. Okay, x squared plus 1 to the power 2. And this is x squared to the power, x squared plus 1 to the power 3. So we take out the lower degree. Okay. And x squared plus 2 to the power 5, x squared plus 2 to the power 6. So we factored out x squared plus 2 to the power 5. Okay, so I almost missed that, right? Okay. Now, what's left, right? So on the first term, 6x is out. So we have 2 left. X squared plus 2 to the power 5. And we have one more x squared to the power 1. And the other term, 6x was out. X squared plus 1 squared is out. X squared plus 2 to the power 6. So we're just going to have x squared plus 2, just one of it. Okay, so it's almost done. We're just going to organize the terms inside the bracket. And everything else is in factored form. We can just keep it. Okay. And in the bracket, okay, 2x squared plus 2, we get x squared, so we get 3x squared plus 2 plus 2, so plus 4. 2x squared plus 2, x squared plus 2, so 2x squared plus 4. And now the bracket can be turned into a parentheses. So we can remove the bracket. But we can keep the bracket too. Okay. So that was an example. So let's look at another example. And this one involves trig function. So we have s of t equals to square root of 1 plus sine t over 1 plus cosine t. And of course, we want to differentiate. We want to differentiate with respect to t. And the function is s of t. So how do I view this function? I view this function as a composition of a square root, u. And u is equal to the entirety of the inside of the root. Can we separate them again? Oh, okay, sorry, this should be a t. This should be a t. Okay, with that perception, you know, differentiating square root of u is easy with respect to u, and differentiating u is going to be a quotient rule. So let's set up. Okay, the derivative of root u with respect to du multiply derivative with respect to dt. At this time, of course, is du dt. So the latter is going to be quotient rule. The former is going to be 1/2 times the square root of u. Multiply. Okay, so we're going to do the quotient rule on this piece. You can do it separately, or you can just do it right here. So quotient rule, 1 plus sine t. So 1 plus sine t is going to be squared. Okay, I'm going to bring up the quotient rule up front. Okay, quotient rule. Okay, denominator square, the numerator we're going to square, we're going to differentiate the numerator, the derivative 1 plus sine t, the derivative 1 is 0, the derivative sine t is the cosine t. Multiply the denominator, which is 1 plus cosine t, right? Subtracting, now this time numerator is copied, and the denominator will be differentiated, which is going to give us derivative of 1 is 0, derivative cosine t is negative sine t. And here we go, we've done the quotient part. And next, of course, we're going to reduce. Oops. Okay. Reducing, we have 1/2 times the square root of the entirety of u. We can think of reducing it, okay, because it's a complex fraction. We're going to do it the next step. So now on this piece, denominator stay the same. The numerator we're going to distribute. Okay, cosine t times 1. This is a cosine t plus cosine squared t. Okay, subtracting. Well, there's a negative sign here, and there's another negative sign here. So this two will make a positive. So it becomes sine t times sine t times 1. So this plus sine t plus sine t squared. Okay, so now what do we get? Sine squared t, cosine squared t, these two together makes 1. Right, so that part is reduced. This part, okay, we can reduce this complex fraction by 1 plus sine t, stay there, right? So we're going to write it this way. 1 plus sine t divided by root of 1 plus cosine t. So as a complex fraction, and we multiply this on both top and bottom, so this piece will be flipped to the top. there. Okay. And we can leave it like that. We can leave it like that. Even though these two actually can be combined somehow. Okay. We can, if you want to combine these two, you will get, because the power, this is the power half, this is power 2, so 2 minus half here. 2 minus half here, so this is left as 1. So this is going to be 3/2. You can write it that way, but otherwise, this one was okay. This one was okay. Okay. And yeah, I think that's all for this episode. Okay. I don't know how long that is. I certainly don't want to make it too long. Okay. So keep on working on these exercises so that you guys can be proficient. And if I have time, I will, work on some other examples. Thank you for watching.